Hello everybody, here we are, and I hope I'm audible right now. In the morning I was only live for 1 hour and something, and then because of the light I had to just simply stop because there wasn't any light. As for right now, let's just simply continue from there on and get the things done. So at least I'm gonna be live for 1 more hour. We will be discussing about the database, exactly how you can build a database, and after that we are gonna be just simply switching to the Xcolor clone project. I hope I'm audible right now. Yeah, I am. So without any further delay, let's simply get going. We just discussed this particular part. First of all, we were discussing about the SQL database, exactly how the data is actually stored in SQL. So when it comes to this, so first of all, the fundamental unit of the, fundamental storage unit of the SQL is a data page or just the page. The size of the page is 8 KB, 8 kilobyte, and 8 contiguous pages, they are gonna be equals to one extent, that is gonna be 64 KB. That simply means the size of one extent is 64 KB. That is the combination of 8 pages, as simple as that. And if 1 KB is, one extent is equivalent to 64 KB, so if you divide it by 1 MB, that simply means 10 to 4 bytes. That's gonna be problematic. 1 MB, that's going to be this is KB actually. 10 to 4 KB is gonna be equals to 1 MB. This is how it just simply goes. Yeah. So if you just divide it by 64, in that case you are gonna be getting 16. That simply means in 1 MB there are 16 extents. Going ahead, this thing we just simply had a look at that. This whole thing is one extent. This one extent is the combination of 8 pages. So ultimately the total size is gonna be 64 KB. And if 1 MB is equivalent to 1024 KB, so if we divide it at the end, we'll get 16 extents here. So this is how it just simply goes. Going ahead, and I think this is something that's not needed. Then suppose the table size is 8 KB, that simply means 80 KB. So the row that we have to insert, that the overall table size is 80 KB. Yeah, the row can be even far lesser than that. So if the table size is 80 KB, that simply means 10 pages are needed for that. Is that so? And that simply means 8 pages plus 2 pages, hence 1 extent plus 2 pages. That's right. Coming back to this, ultimately suppose if there's any row, so we'll calculate the size of the row. Once we know the size of the row, on the basis of that thing, we will see that how many, ultimately we know the size of one row, right? So if we know the size of one row, so if there is a row of SQL table, so we'll just figure out the size of that. If the size is, suppose it can be somewhere like suppose 80 bytes or something. So suppose this is the size of that particular row. So once we know the size, so we can actually check how many pages we can have in a page. So how many rows we can have in a page. So if I talk about one page, that is equivalent to 8 KB, and 8 KB in the sense, if we see how many bytes are gonna be there, so 8 into 10 to the power 3, that simply means 8,000, around 8,000. Yeah, so around 8,000 bytes we have. So if we just simply divide it, that simply means in one page we can at least have 100 rows over here. So this is how we just simply calculate the number of rows we can have in a page. Now we know that these many rows we can have in a page. After that, what we'll do, we will actually create a range. So we'll have a root layer here at the top. Just below that, in the middle, we'll have intermediate layer. There can be many intermediate layers, and then we'll have the leaf layer. And then we are starting from here. We already know that one layer can, those 10 pages should have this particular range. So we will start from the top, and suppose we are looking for 500. So even 500 is not here. Suppose we are, as per this one, the range is from 1 to 4,000. So if we have 24 range over here, 2400 ID, so we'll come back here. 24 is greater than 2001, so we'll come back here, and now so we'll come back to this one, and between 2001 and 3000 we'll just simply get the range. So ultimately what we are doing, that first of all, how can I put this thing in words? First of all, we are checking the row size. so or row size. Once we got the row size, after that we are checking like how many pages how many rows we can have in a page. So page, how many number of rows it can just simply take. Once we know this thing, and then we'll see how many if we know that this page handles these many rows, so we'll check how many pages do we need. So ultimately we're gonna be checking the number of pages. Once we know the number of pages, that simply means we even know the range. So once we know the number of pages and the range, we will create this B tree structure over here as per the calculation. Once this is ready, then we'll be able to just simply what we'll be able to do, we'll be able to just simply query the data really quickly. It's just as simple as that. Coming back to this, B plus tree leaf page does not store a fixed number of IDs and or rows. It stores as many rows as fit in the page. The 1 to 1000 ranges in diagrams are logical key ranges, not a statement that exactly 1000 rows are. Large rows that don't fit in a page are split using overflow log pages and accessed through pointers and all. So that everything just simply sort of makes sense. Coming back to this one, let me just simply delete all these things. This is just the overall idea about how this works in SQL. So let me just simply copy as PNG. I think this should be enough, and hopefully right now this is fine. Just a minute, give me a sec. Where am I supposed to be keeping this? And 15 designer database, probably somewhere here I'm gonna have it. Alright, let's continue with this. So we have talked about this particular thing, and that is a good thing. Now how about I actually need a pen to make it, and I cannot really use my pad here. In that case, I need to go live from where? From window. Probably. Yeah, as for this database thing, once I'm on Ubuntu right now, so it's not really possible to use the pad and just simply draw something on the board. So whenever I am on whenever I'm on window, at that time I'm just simply gonna be going live, so that it's easy to just simply draw the stuff. So let's keep this pending. We'll be just simply getting this particular thing done. Pending, that's gonna be going live. Alrighty. Apart from this particular thing, 15th and 16th one, MVC architecture. And what is this MVC architecture? Ultimately we will have model and views and controller. So let me just go ahead. Alright, let's talk about MVC architecture. And in this particular section, let me even share the entire screen. That would be better in that way. Alrighty, I hope you can see that. Coming back to this MVC architecture here. So ultimately, when it comes to MVC architecture, that is nothing but models, views and controllers. And nowadays this MVC architecture is actually implemented in a different way. But earlier it was mainly for scalability, extendability and maintainability, independent of tech stack. So that it doesn't matter which tech stack you are using, that's gonna this particular structure is going to be used. And at the end of the day, suppose what is this menu customer, there is a menu, what customer sees, that is the menu. Then the customer just simply makes a request to the waiter just simply goes to the chef. So customer talks to the waiter goes to the chef gives the food, and the food comes back to the customer, and this is how it just simply goes on. But in MVC architecture, V stands for your database. That particular thing is handled by model, especially nowadays. View is mainly what users is, and that is always like this, so no problem as such. As for the controller part of the code that we classify as controller, will act like the waiter of the restaurant. Controllers take the responsibility of accepting the request and sending the response. This is sort of fine. So what is happening now? View is still being used the same way. Controller is sort of still being used the same way. On top of controller we have services, and after services we have repositories. So there are even more layers on top of this controller nowadays. As for the model is it's not like it will have the business logic. Rather, it is merely responsible for handling the schema section nowadays. Case study, Ruby and Redis programming language or framework on top of Ruby. Alrighty, this particular thing is done. So ultimately, when it comes to MVC usage, so Ruby on Rails uses this, and similarly for Ruby and Rails there is something called OR framework that just simply built on top of Ruby language, and it just simply uses the MVC architecture. Then we have libraries and framework. It's pretty simple. What is a library? Library is a software that does just simply one thing. So of course it is some code written by somebody that's available online, and you can use that particular code using a package manager that can be npm, and you can just simply install that code and just simply start using. So that is just a library. When it comes to framework, so framework is the bigger part in the sense it is the combination of many libraries. Framework is mainly responsible for getting a task done using libraries. So it's just done. It is just like that. Framework has more functionalities. It is versatile. But as for the library, it is just simply used for doing one thing. Problem with the MVC: too much simplification of everything. One piece of code will start doing more than one thing on a granular level. Nowadays, front-end code base is kept apart from the server side code base, and MVC doesn't talk about that. Yeah, that's right. Coming back to this particular thing, yeah, this is what actually being used nowadays. So when it comes to overall how that your server is structured, so there is routing layer, then after routing layer there is validation layer, after that we have handlers or controllers. The request goes to the service layer. From the service layer the request actually goes to the repository that simply talks to the database. Apart from this particular thing, we have the config, schema, migrations, utilities, GTOs, all these things. And okay, that is it. Service, repository, DB. That is it, nothing else, as simple as that. As for their definitions and all, you can just simply read their definitions over here. But routing layer, validation layer, taking request and all, that's pretty simple, especially if you want to have a look at the code. It would even make more sense if we just directly have a look at the code. And coming back to this, these are the layers that we have just simply been talking about. So nowadays we have many layers, like we have config, we have controller, we have DB, DTO, helpers, we have middlewares, we have repositories, we have routers, we have services, we have utilities, we have validation layers, we have and server.ts we have. So what happens that first of all the request actually comes here. From here router handles the request. Router actually sends the request to the controllers or the handlers, you can call them anywhere. From the controller the request actually goes to the service that handles the any service related part. From the service the request actually goes to the repository that simply handles the job of me. It's just been 15 minutes. Why am I facing the network issue? This is sort of fine, it's not bad. I don't know, for some reason it just simply. Alrighty, so we've talked about somewhat this MVC architecture as well. Going ahead, we actually have to go through a lot of things. As for this one over here, we have to talk about the database designing. I can only talk about this when I'm actually able to make diagrams on my board, and that can be done when I have my pad, though I have it but Ubuntu doesn't support, so I'll have to switch to Windows. So this is the topic remaining for going live on, and let's go through this one. HTTP protocols and APIs, that's again pretty simple. So HTTP protocol is nothing but a rule. So a rule that makes a rule that's been made so that two web applications can talk to each other, or yeah, sort of can talk to each other. At that time, the protocol that's been defined that is called HTTP protocol. The main thing is that hypertext transfer protocol. and we have the APIs. In the APIs we have REST API. When it comes to the use of HTTP, so two websites they can talk to via HTTP requests. At the time HTTP protocol is used. Going at exactly how many things are here. So HTTP, primary communication mechanism between machines. So that's simple. If you two machines want to just simply talk to each other, how we will use HTTP can be different for different cases, but under the hood most of the common communication is gonna be done by HTTP. As simple as that. Coming back to this one, it is an application layer network protocol. That is right. Application layer network protocol. It is reliable protocol, hence dependent on TCP protocol in the transport layer. It is actually dependent on TCP protocol on the transport layer. So on top of TCP only HTTP is built. It is a set of rules that generally govern how you can send hypertext over network between two machines. So hypertext in the sense text with the hyperlinks and all. So how you can just simply what is hypertext? Hypertext is a text or document that contains links or hyperlinks to another text or document. So how you can send that kind of data? That is something what's handled by HTTP. When there are different versions of HTTP, and we'll just simply quickly go through them. It will define how machine will format, read and transmit hypertext from one machine to another machine. That's right. Throughout years, HTTP has developed to become more general purpose application layer protocol, and it is now capable of just not just transmitting hypertext but mostly any kind of data. So earlier it was mainly built for sending hypertext data, like data with hyperlinks connected to another hyperlink or another document. But as for right now, it is able to send images, text, JSON data and all. Mostly we've used this for JSON data and all. So this is how it just simply goes on. And apart from this particular thing, we have some versions over here, like HTTP version 1, 1.1, 2 and 3. Even after that we got quick here. So there was no support of persistent connection in HTTP version 1. In HTTP version 1.1 we got the persistent connection and response can be streamed in R. Most of the services they still use HTTP 1.1 as well, and some services have started using HTTP 2 as well. It is just more improved. So as the newer versions rolled out, there were more and more functionalities. And nowadays when it comes to use like the third one, so instead of direct TCP, it started using it quicker. So let's talk about versions of HTTP and evolution, MDN. Hopefully I'm gonna be getting a good one. Hypertext transfer protocol. Here we are. Introduction, application layer, the hypertext transfer protocol. Then it has a few versions over here. HTTP version 1.0. So it is supported in this context of in summary, HTTP 1.0 got much more robust than 0.9 version. Even there was 0.9 version before even that, but okay, never mind. So the HTTP header is enabled to send and receive different file types and exchange relevant metadata. So 1.0, then we got 1.1. So I'll have to go through it all. HTTP relies on TCP IP to work. That is also right. Coming back to this one, HTTP 1.0 supported header, versioning, status code, content type, and new methods like get and apart from this particular thing, 1.1 supported host header, persistent connections. So the first one, this particular section, 1.0 did not support persistent connection. So HTTP 1.1 just supported that. And new methods like it even supported new methods, patch, delete, connect, trade, and all these things. Earlier it just supported get, now it supported more. Then we have continuous status, persistent connections, and host headers and all. Going ahead, version 2 that simply supported request multiplexing, request prioritizing, automatic compressing, connection reset, server push. So ultimately, as newer and newer versions came, it just started supporting many more and more features. The most basic thing can be that 1.0 version did not support header. It did not support header. It did support header. It did not support many methods like many methods, and it did not support the persistent connection. So 1.1 actually supported a persistent connection, and it even added more methods on top of that. And then HTTP 2.0 actually added more things like multiplexing, prioritization, compression, and all these things. And lastly 3.0, it actually started using quick instead of TCP protocol. So H3.0, where is that? Just a sec. QUI. Okay, here it is. See. So HTTP 3.0 is an internet draft different from the previous HTTP versions, which are requested for comments or blah 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 blah. Okay, yeah. The main difference between HTTP 2.0 and 3.0 is that the employed transport layer protocol. Ultimately transport layer protocol is the main difference. In 2.0 we have TCP connections with or not TLS, HTTP and HTTP. In HTTP 3.0 in turn is designed over quick UDP internet connection. So it is actually designed on quick protocol, quick UDP internet connection. So quick UDP internet connection, this is the just full form of this. So in short, is a transport layer protocol. Quick is a transport layer protocol with a native multiplexing and built-in encryption. Quick provides a quick handshake process besides being able to mitigate latency problems in a lossy and slow connection. So ultimately, it is better. It is nothing but a protocol that just simply does the job, and it is built on top of UDP internet connection. So mostly UDP is the quicker, right? So if you talk about TCP and UDP protocols, they are quicker. And then quick does some changes on top of that and just simply makes it good for makes it good for making reliable connections as well. So in addition to potential benefits inherited from quick, another relevant characteristic of HTTP 3.0 is that it always creates an encrypted connection. So it is similar to always deploying HTTPS in current HTTP 2.0. So it also creates always encrypted connections and all. So in summary, HTTP 1.0 it had less methods, and it did not have the persistent connection. 1.1 actually introduced the persistent connection and more methods, and then 1.2 I think 1.1 is done. Then let's talk about 2. So 2 just simply added multiplexing and prioritization and compression related stuff, and at the end H3.0 actually started using quick as the protocol to just simply make connections. So this is how it just simply goes on. So that is it. Whenever what is API? So API is nothing but as simple as that. So if you want to talk to the online world, so you need to have an API. So application programming interface. API is a mechanism with which the outer world will be able to interact with our software. So suppose we wanna talk to a software, so at that time we need an API. So this is just a mechanism, this is just a way to just simply talk to a software, and it can be talking one software with another software, or it could be that you talking to the software, or it could be also like there is a software that has pre-built APIs. So pre-built APIs in the sense using the features given by that particular software. So if there is a software and you are using the features of that particular software, so even those features, if they've been provided you to use, they are gonna be APIs as well. So this is how it just simply goes on. And React Coach browser, how we are going to write our own APIs. So we are gonna be writing our own APIs using REST, and probably in future I'm gonna be exploring graph. I'm gonna be exploring something else that I've forgotten. Yeah, gRPC. So if we talk about most widely used REST APIs, so ultimately they are REST API, gRPC API, and GraphQL API, and they are nothing but the rules written by somebody, written by of course a group of people, and they just simply specify that okay, at this time you have to do this, the data format should be this, you have to use JSON or you have to use XML. Just this is how it just simply goes on, and this is how the job gets done. Hopefully it's not going to take a lot of time. We have gone through this. Coming back to this one, 18 and 19, designing DB schema and designing this. So designing DB schema makes sense. We will try to design the DB on our own. So ultimately we have to sort of design a database. Let's quickly go through this. It might not be understandable initially, but ultimately how to design a DB schema, this try to ensure that okay, this is there is something called normalization. Again, what is normalization? This is set of rule that makes sure that the way you have designed your DB, that is right, things are not duplicated over there. I mean, this is what it covers. As you keep building, you automatically get to know more about it. Okay, so try to ensure that there is as less data duplicacy as possible. It follows normalization, and apart from this particular thing, understand the two tables can be related, and hence the queries will also be imported. So you have to be far-sighted in the sense you have to know that later two tables can be related and all. Keep in mind that actual data, actual real life app, okay, try to communicate your thoughts. Design booking.com's requirement is that owners hotel should be able to list a property and rooms on the platform. Users can book a room of a hotel. It's easy, it's not really big deal. Users might want to book some hotels, review supports. So entities, users, hotels, review, booking, wish list, rooms, and time to design this particular database. So let's do one thing. Next time onwards, whenever I'm gonna work on this, I'm gonna be just simply starting from here, and we'll design the database. So some to do's gonna be here. Come on. What? It will mainly be done tomorrow, but as for right now, when it comes to do's, so first one, design databases mentioned here. And apart from this particular thing, Udemy was something that was given as homework, so we will Udemy, so ultimately design DB of Udemy. So these are the two things that we have to just simply get done. And when it comes to this, so they are mainly talking about book my show over here. So if I just simply scroll down, so these are the features that we have to implement over there. And apart from this particular thing, 1 month window, 3 month window, that is right. So at the end of the day, room category is gonna be like this, room ID, and alrighty, it's not like everything's built here. Coming back to this, there is something called date of what. The important thing is that whenever you try to go on book my show website, so at that time they show exactly whether a particular date is a free available or not, or if you are just simply booking any hotel. So mainly let's talk about hotels. So whenever you go to the hotel is actually able to show you that the rooms of the hotels, they are actually free on a particular date or not. And for this particular thing, we can pre-generate the data. Pre-generating the data in the sense, suppose down 30 days down the line, first of all we will make a table where the entries of all the 30 days are there, and after that, as we keep getting hotels booked, we will just simply we'll mark them booked, and if some of them are not booked on that particular day, then that's gonna be of course free. As for this particular thing, of course we are gonna be digging deeper into this. So design database mentioned here, and of course we have to design Udemy, and that can be done only tomorrow, of course. What is here? Design DB schema. Let's see. So ultimately DB designing stuff is here, and this particular thing is gonna be discussed tomorrow, exactly why we have, and how it can actually be designed well. So we are gonna be talking about this particular stuff, exactly how the things are gonna be the way they are and why they are. Coming back to this, so when it comes to a room, so room has the room ID, hotel ID, DOA, date of availability, booking ID can be null, price, and room number. So this particular thing is something that makes sense. If any room has the booking ID, that simply means that is booked, and if that did not have, that simply means that is not booked. And we'll actually have it a day wise date, so this particular section will have a date. So we'll pre-generate for 30 days down the line, 50 days down the line, depending on the need. Okay, this is for the Twitter, I think. Yeah, DB of the Twitter, then we have the DB of the booking.com, and then we'll generate the DB of the Udemy. These are the three things that we have to keep in our mind. So to do job, we have to generate design databases. First one is gonna be for Udemy. First one is gonna be booking.com. That's already generated here. We'll just simply go through that really quick and then we'll generate it on our own. The second one is gonna be Twitter. Third one is gonna be Udemy. So these are the three things that we have to keep in mind, especially when it comes to booking.com. So we have to the main thing is gonna be how you are gonna be telling the user that this particular room of this particular hotel is actually available or not, whether it's been booked or not. And the simplest thing can be that you have to pre-generate the data. So you have to pre-generate the data for 30 days, and initially everything is gonna be not booked. Ultimately booking ID is gonna be null, and as that keeps getting booked, just set the ID to that particular user's ID or order ID, and ultimately booking ID. And if something has ID as null, that simply means that is not booked on that particular day, and if that has a particular ID, that simply means that particular room has been booked. So this can be the easiest way. Again, all these things are gonna be done very soon, of course tomorrow, and this is gonna be the main section for tomorrow, and probably we are gonna be talking about this particular stuff as well. So coming back to this one, two things: going live on this particular, like how you can create the database, and in fact actually creating the database over here. Go live on. Alrighty, so this is till this we've covered it. I think that is more than enough. Let's just simply talk about some actionable stuff, because this is nothing but the theory, right? So it's better go through some actionable stuff. What time is it? It's 11:56, because just after some time I even have to go through which section that is called I forgot. Yeah, I have to work on Excalibur clone project. That is something I need to get done as soon as possible, but before that let's just simply get something that is sort of actionable. And as I started this debug section the day before yesterday actually, so we talked about all these things. We talked about AWS come on, how to connect to SSH EC2. Alrighty, so this is the thing that we covered over here. Connecting to someone's machine, this can be done only when you have a machine. Virtual machines we talked about, and you can just simply get the virtual machines from cloud providers. We have some cloud providers inside etc host. If you want to point a domain, you can do that, and this is just a normal definition, and the job is done. Coming back to this, we have to just simply revise this stuff as soon as possible. Deploying to virtual machine and CI/CD pipeline, this could be the interesting stuff. So coming back to this one, LSOF, I mean this is understandable. If you are running any command, any process is running, so using this particular command, LSOF will give you all the commands. LSOF-I colon 3000, so this is gonna be the port number. So it will give you the process running on that particular port number. As simple as that. Daemon is nothing but a program that is a process that is running in the background and just simply getting the job done without user interaction. That's just the daemon. Let's talk about process managers. We have PM2 over here, we have Forever over here. I haven't really explored this Forever, how it's used, and also probably we are going to be diving deeper into this, and this particular section needs to be done right here. SSH already. Deploying a web application on EC2 with GitHub and Apple YSSH. I think this is the thing that we have to just go down. So they are mainly covering how you can just simply deploy something. This is the recent link that I added here. They use Terraform, and I have no idea exactly how this Terraform stuff works. Just a minute. Terraform is an infrastructure as code tool that lets you build, change version cloud on-prem resources safely and efficiently. At the end of the day, this is something that I have to learn well, and yeah, so I'll need to learn about Terraform. That simply means going through it is not really good stuff. And then we have something called Apple Boy. SSH for GitHub Actions. Okay, fine. So SSH for GitHub Actions is a powerful GitHub action for executing remote SSH commands easily and securely in your CI/CD workflows. Built with Golang and Drone SSH, it supports a wide range of SSH scenarios, including multi-host proxy and advanced authentication. Automate server tasks with Appleboy SSH action GitHub action. So ultimately, using Appleboy SSH action, you will be able to SSH into the machine. So you have GitHub actions. From there, you are going to be using Appleboy SSH action. It will be SSHing into the machines. Is that so? And then it will be just simply getting the job done. Core concepts, input parameters. This action provides flexibility. SSH commands. We'll see how it's used. Here we have an example. So name on push build Ubuntu and execute remote SSH commands using password. So Appleboy, we are gonna be SSHing into what? We are gonna be SSHing into the. I think we can SSH into the EC2 machine directly using Appleboy. I think so. So if you want to access, yeah, who am I and this successfully this. So we need the SSH keys for it. Secrets username. We'll see. Time to do the things in action. As for this forever, PM2 is just simpler. How about this? We have to just simply install this. Once installed, npm install forever monitor. After that, forever start app.js. We have to just simply run this command. It will just simply start running the command. Oh, interesting. Start, stop, all start. It is just like a PM2 only. And forever mean what is this? Max. So the max process that we want to start, that is 5 examples. So this particular thing will start, and it will start 5 times. So as per the course of your device, suppose if you have 10 cores and all, so you can start it those many times. And it will just simply start the child process. Okay, good stuff. As for this one, SSH action steps to generate SSH key, that's done. Save private key in GitHub, passphrase of secrets and variables, that is also done. Create .github workflows file name.ml, create folder in EC2 machine and clone the project. Run this, push GitHub and use ngrok at the end to get the link. Ngrok. What is ngrok? Deliver your apps API is on localhost production. What is this? Deliver way worse than tunnel to localhost. How this ngrok works, I have no idea. Okay, coming back to this, do it again and make sure everything works. But there's no code as such, so we cannot really do practical stuff. So let's go to part 2 right now. Steps to do the things. So buy a domain, we've done that. Steps to remember. Let's go here. Deploy monorepo, adjusting consoles, these are the things that we actually have to do. This. Let's see whether we are gonna be actually capable of doing that or not. You may have to create a rules set to protect a production branch from pushing it to it directly. Branch protection rule. Redirect to an IP with URL without DNS. Redirect to an IP with the URL without DNS. May not work on Windows. Yeah, that's right. It doesn't really work on Windows, but it works on Ubuntu. Domain name, DNS domain name systems. So we have SSL, secure socket layer. We have ICMP, Internet Control Message Protocol, important domain websites. Then we have DNS trigger over here. Let's talk about this nginx. So sudo this is how you can just simply use nginx. So sudo vi edc nginx engine config. This is where you have to change the stuff. Once you change the stuff, like you have to change the configuration inside nginx config, and once you done that, you can reload it. Ultimately, you will be creating two instances, dev and prod. These files are for dev and prod respectively. Just add the code in the right file and reload nginx. So this is the nginx configuration. So when it comes to nginx configuration, so I'm gonna be getting a request on port 80. Staging job this the request is actually gonna come from here on port 80, and I'm actually gonna be redirecting to this, and the request is gonna come from this on port 80, will be redirecting to this. The same thing will happen for this. The same way we have for production as well. So the only difference is that the URL has the staging.ws server.code in the code, and the production has the direct URL. Makes sense. Alrighty, we will be going through it. Deploying an EC2 machine. This is the doc article sort of, and YAML files for CI/CD GitHub. So we have staging, we have for production, and this way we can steps to run a project. Setting up EC2 access. Create an EC2 instance with appropriate Amazon machine, usually Ubuntu or Amazon Linux. If needed, create attach additional EVS volume. Elastic. What is the full form? Okay. Then create an SSH key player via AWS console. Save the private key securely. That's right. Add the public key to EC2 instance automatically during the launch via key pair selection. That's right. SSH into the EC2 instance using the private key and instance public IP. Okay. Installation environment setup. Update instance package. So ultimately run this particular command. Install Node.js npm pm2 process manager and nginx as reverse proxy. Configure nginx for reverse proxying to your Node.js application port. Ensure that the EC2 security group permits inbound traffic custom ports app this right. If needed 3000 and 8080 just for checking purpose. Project setup. Develop your project locally with branches dev or main, and production as planned, and push code to GitHub. Store the private SSH key used for server access securely as GitHub secrets for CI/CD pipeline. On EC2, initialize Git and clone the repository. Install project dependencies npm install. Run app using pm2 to keep it alive and manage process restarts. Access and testing. Access your app via public IP and respective ports. Use nginx to map a domain or subdomain to the server IP with reverse proxying. Optionally use domain provider like Hostinger for DNS and to point to your EC2 IP. CI/CD pipeline. Create two YAML files. Suppose this and this. CD staging ML and CD prod ML with GitHub Actions or another CI/CD tool. Configure pipeline to SSH into EC2 pull code. Install dependencies and restart the app. That's fine. What? Configure pipeline to SSH into EC2. Yeah, that's right. Test confirm successful automation. Additional recommendation. Consider setting environment variables securely using AWS System Manager parameter to store or GitHub secrets. Okay, AWS System Manager. This stores what? It stores the passwords. This. Okay, coming back to this one. We have to do everything in action. So whatever I have gone through, all the whatever I've discussed here, either today or tomorrow, we'll just simply get everything done. Coming back to this one, sign console, and apart from this particular thing, I have to add cert. I don't know how it's done, but some to dos are gonna be here. Arey bhai. To dos. What are the to dos? The to dos are cert manager. I don't know what's the name of this, but ultimately I should be able to add the certificates so that I can send HTTP request to cert manager on Nginx. So this is what we have to do, and be able to write the CI CD pipeline on your own. So far what I've been doing, I've been just simply copying and pasting. Now onwards I'm gonna make sure that I'm actually able to write the CI/CD pipeline. In case I'm not, I'll just rewrite that. Okay. Set PM2 to auto start your app on system reboot. Okay, fine. Configure HTTP with let's encrypt on Nginx. Okay, fine. Regular backup your EC2 instance and the data volumes. The volume, it can be backed up. That's right, but where? We can create a backup, that is for sure. So if it goes down, then another one comes up, and that time just simply gets the data from there. This backup related stuff I learned in the Kubernetes, but we'll see if we can do the same here. Come on. Use IAM roles when possible for instance permission instead the access key. Monitor your instance using CloudWatch or other monitoring tools. We can use Prometheus or Grafana here. So yeah, these are the things that we actually have to go through. So it's gonna be time for an action. Coming back to this exactly, let's see. Come on, what all is covered here? What is AWS? EC2 servers, creating new EC2 SSH into server, install repo, try hitting the server, Nginx, certificate managers. Alrighty, chmod, we have to just give it 700 anyhow, clone the repo. If you, as for the server, we will be creating the server on our own, so we do not really need to worry about it. Install Node.js, install dependencies in this some server. Try visiting security group. Nginx is an open source software, reverse proxying. Okay, that's fine. It just simply helps reverse proxying this stuff. Okay, let's start the backend. Start off. About this, I have to know more about certbot. Let's have it at the top. I think I already have it. No, I don't. So certbot. Yeah. So I have to know more about this certbot and exactly how I can use this inside Nginx. So certbot instructions. My HTTP website is running. Software is gonna be Nginx. System is gonna be Linux using pip or certbot instructions, snap. Okay, so what next? To use the certbot, you will need comfort with command line. Okay, then and HTTP website that is already online with an open port. This okay, fine. Which host is on server, which you can access by SSH with the ability to receive optional if you want wildcard. This don't have requirements. Snap support, SSH into the server. So SSH into the server running on your HTTP website. Install snapd. You will need to install snapd and make sure that you follow any instruction in our classic snap support. Then remove certbot auto and any certbot OS package. If you have any certbot packages installed using this, all these things apt DNF, you should remove them before installing the certbot, to ensure that when you run command certbot, the snap is used, rather the installation from your OS. So sudo get apt-get remove certbot, did this remove certbot. Okay, install certbot. So sudo snap install certbot like this, sudo snap, and if I selected that pip here, then in that case what would happen? Pip is nothing but apt, right? So I have to go with this one only, sudo apt. Interesting. I thought it would be, I thought I would have to struggle a lot, but all the steps are here, so that's gonna be bit easier. Anyway, sudo python 3 this nv, this is for python here. Sudo dnf remove this. Sudo apt update install python 3 this. Well, this is not what we are looking for, right? So pip is mainly for python, we don't have to go with the python, we have to go with the snap, or we can go with nothing, we can go with only snap, as we are using nginx over here. Yeah, that's the only option we have, hence we need to follow all the steps over here. Once we have followed them, choose how you would like to run. What all do we have to do? Install snapshot, we've done that. Then we have removed. Okay, install certbot, that is installed. Prepare the certbot command line, sudo ln this. Choose how you would like to run the certbot, either get and install your certificates, run this command to get certificate, and have certbot editor your nginx configuration automatically to serve it, turning on https access, just like this, or just get a certificate. So this way we can get the certificate. And then sudo certbot renew dry run, so it will just simply renew the certificate, the command line. Wow, it's not that difficult anyway. Then confirm that certbot worked. So troubleshooting. Alrighty, we are ready. And apart from this particular thing, I have to go to AWS. And how does this manager work? What is the name of this manager? The name of the manager is we'll create simple backend, we'll deploy that, and then we'll see what actually happens. Come on, where is that? So AWS system manager, that's the one, right? On GitHub secrets, this is easy peasy. Like on GitHub you can easily store the secrets. So that can be stored on a particular file. So if that particular secret belongs to this file, so I have to just simply go to settings and the secrets and variables and actions, and this is where we can just simply have, even I have some of them. So ultimately, coming back to this, if we store secrets on GitHub, I can only access them inside a CI/CD pipeline, and for EC2 environmental variables, I need to save them in AWS. What was the name of that? System manager. Not necessarily, these are two separate things. GitHub secrets, if you store secrets in GitHub action secrets, they are available inside GitHub actions workflows. They are not available directly to your EC2 instance. You access them in workflow, like yeah, just like this, makes sense. And or like this. EC2 environment variables, you have multiple options. Store directly on EC2. I mean, that's the easiest thing. Or use PM2 start what? This or source. I store directly on EC2. These are gonna be the environment variables. Source uh, .env. Then or use PM2 start echo system config.ns. This is the simplest approach for small projects. AWS System Manager parameter store secrets in Amazon Web Services parameter store. So ultimately, we are gonna be storing in there. Then EC2 fetches them. So AWS SSM get parameter this and this. So advanced centralized. How does this work? Tell me step by step. Alrighty. Meanwhile, let's just simply keep reading. So, अरे भाई इतना भी नहीं, just a sec. Yeah, so it is just simply saying, asking me to just make a request. Centralized, encrypted, I am controlled, no secrets committed anywhere. That's right. AWS Secret Manager. We have for production system, many teams use Amazon Web Services Secrets Manager. Isn't it the same? Option C and 2 B. Amazon Web Services parameter store we have. Amazon Web Services secret managers we have. Okay, instead of parameter store, because it provides secret rotation, better secret management and versioning. Okay, so common production can be developer, GitHub Actions, EC2, deployment secrets, SSH private key, AWS credentials, etc. They are gonna be inside GitHub secrets, application secrets, database URL, all these things they are gonna be inside AWS parameter store or secret manager and fetched by the application. This way GitHub never needs to know about your production database and all. For your Node.js app, EC2, a practical setup can be GitHub action secrets, GitHub secrets, EC2 host, user host, EC2 SSH key. So we'll have this, and then AWS parameter store, database URL, and all these things. Parameter store, or it can be inside what we have two things, right? The first one is the AWS system manager parameter store. So either it can be here or it can be here. AWS system manager parameter store. So ultimately we have the parameter store and we have a secret store, secret manager. Okay, fine. The question is how it can be used. So you store the secret in parameter store, AWS console system manager. Inside the system manager we get the parameter. Create a parameter. Let's do it. Your authentication information is incorrect. Why? No thanks. Coming back to this, we have to go to system manager. Okay, system manager. So inside the system manager, how many things we have? First of all, it's loading. Okay, fine. So system manager manage nodes at scale any environment variable. It is simply used for that. Create a new. So ultimately this can be used. We have to parameter store. We have to just simply select EC2 a policy needs to be attached. So create IAM role, attach the policy. So the EC2 needs to have this particular policy. So EC2 IAM role can access SSM. So we can create a role and we can attach that role to a particular EC2 machine. Without this step, AWS will reject the request. Install AWS CLI, usually already installed, SSH Ubuntu and your server. Give me the real value, not the encrypted one. So ultimately over here with the decryption, okay, that's fine. Extract only the value instead of the whole JSON. Output is gonna be this. So ultimately output is gonna be the text. Export as an environment variable. So whatever you get, you have to just simply export this as an environment variable. Hence that's gonna be exported. So inside data echo $bash URL, you are gonna be getting this. Your Node.js app can use this normally. Automate during deployment. So during deployment, before starting app, export and restart KM2. Create a script bin bash, and this is gonna be running. Great. Better approach for multiple secrets instead of this. Making 4 AWS calls every startup managed teams run. Get parameter path by this, which returns everything in one request, and you AWS parameter store encrypted secrets, and then EC2 IAM rule attached, can call SSN API, node startup, yes, this URL PM to start. Okay, this is fine. And how about this one? Ultimately wage are there, what else? AWS Secrets Manager. How can we use this? AWS Secrets Manager works very similarly to parameter store, but it's designed specifically for secrets. So store, secrets, encryption, IAM control, all these things are gonna be here. Parameter store is mostly free. Secret store can be paid. Enterprise or production, small or medium apps. So parameter store is enough for most personal projects and startups. This is enough. For larger production, secret manager is gonna be preferred. Okay. That makes sense. As for this one, larger production systems and all this, you are just simply gonna be going on. Alrighty. Create secret AWS console, secret manager, store new secret this way. Attach the policy, get it. Once you got that, JSON format, you will have to install this as well. And once you install this secret manager, so you are just simply gonna be making a call. Before that, you need to be authenticated for that as well. Okay, quite a lot of steps are here, but ultimately it can be done. There are ways to do it, right? So we have two options here. We can go with the, what was the first one? Parameter store. Parameter. and the second one is gonna be secret manager. This is the one we have. When it comes to parameters, so this is it. So inside applications tools, we have parameter store. We can just simply create a parameter store. We can name it testing store. Give it the value string list or secure. Encrypt sensitive data using KMS keys from the current account to another. Any value string list or my current account ID is gonna be base alias AWS SSM. Okay, that's fine. Parameter value to encrypt with the selected parameter value. Okay. Now we have to provide some values over here. So parameter value to encrypt with the selected KMS key. We can give it anything. Something that needs to be encrypted. What do need to provide as a value? Key value parameters or just the value? You are creating a securing. Okay. So parameter name, my app database URL and the value. So ultimately JW2 secret and this. So a common shortcut is my app this. अरे भाई स्टोर क्या करना है? What is the key name here? Alias is gonna be this. Key ID, and this is where we have it. So suppose I'm gonna be storing this, then what the hell? Then I should be. Suppose it's there, create that. This is the key for it. So we'll have to create the environment variables for all one by one. So this is the name. Using this name I can just simply access that, and this is the value, and that is it. We can just simply edit it anytime, and when editing we can just simply edit this. We can just simply change the key. The key cannot really be changed though. This is how it just simply goes on. Got it? So it turns out, yeah, we can have the things there, and that's what I wanted. I didn't focus on one thing. Suppose the name is gonna be parameter name database database URL. The key is gonna be this only. Secure, create. Once created, we have the database URL over here, and if I come back here, it's good we have it. How can we use it? Probably we'll have to make a parameter store. Ready to scale, enable higher throughput to handle more API calls, manage your settings, to increase TPS, public parameter settings. parameters store this. This is the first one, AWS secret parameter store. Second one, nothing's here. RSI, what the hell? How to use AWS this? Okay, fine. So now they are giving the proper value answer, that create a string parameter and just make a request like this. Good stuff. So ultimately what all they are saying, put parameter, name is gonna be this is gonna be this. So you can do the same thing using command line. So you can just simply put the parameters, organize parameters with hierarchies, so you can just simply organize them well. Reading parameters, so get parameter, so you can just simply even get the parameter, and get parameters, you can get all the parameters as multiple parameters by name, and get all parameters using parameter store in applications. So if you have any applications, suppose the Python one, so you can just simply make a request. In Node.js you need these from SDK, you need the region, then you simply make a request. You are going to be getting the parameters. Once you got the parameters, get all the parameters, you just await get config. Get config is this. So from here you can actually get all the parameters and all, and from here my app and production. In this case, okay, that's fine. Java, Lambda, using parameters, yes. Okay, that's great. So next time whenever I'm gonna deploy anything on AWS, so at that time I'm gonna use this, and this anyway is a pretty good one. So we actually have to do a lot of things that we in action. Anyway, that makes sense. Leave it. Let's close everything. So almost the theory section is done. Now we have to just simply do it practically. That simply means we have to work on a backend. Once the backend is created, we have to just simply deploy that. Once that is deployed, we have to get the environment variables from AWS parameter store, and we have to implement Nginx and all. So we have to, this is how get the things done. One more thing, if we create any EC2 machine, so we'll have to assign a role over there. The question is that when it comes to roles, so so if I want to use secrets, so I'll have to assign a role to the EC2 machine. EC2 machine is actually able to access that. So if the role that I create, if I'm gonna create a role, commonly used services, so use cases, allow an AWS service like EC2, Lambda or others to perform actions on in this account. Select a trust AWS service, AWS account. Allow an AWS service like EC2 or this, so EC2. In this particular, allow EC2 instance to call AWS services on your behalf. That's right. store. We don't have any service as such. These are the rules that we have by default. That simply means I haven't created any. And do we have role? Not role. What is that called? Parameter. No, do we have a store? Nothing. These are the policies. Okay, so we'll have to first of all know the right policy so that we can create a role with that. And once the role is actually created, suppose not I am, this is the role that we have. So if I click on this, then what can I do with this role? Once this is the role, I can access this particular role inside the policy, can't I? Coming back to AWS, this, yeah, it can be accessed, and then it is attached, and this is how we are gonna be getting it done. And yeah, let's see how it's gonna be going on. We can even create the user groups. There's a lot. Anyway, as for right now, I'm just simply gonna take a break. Let me just simply delete this. We have got a lot to do, but at the end of the day, we have to work on our project as well. That's the most important thing before even doing anything else. We have to get this project done as soon as possible. I think this is the one. So the next time, like after half an hour or something, I'm gonna be back, and then I will start working on this project. And there were to do's here, and one of the to do is bounding boss is of course here, but we have to fix the shape select for circle, ellipse, and image. So this is something that we have to fix, and then there's a lot to know. There's a lot to know, there's a lot to do. So we'll keep doing that. That's not really a big problem. And there's a lot to revise as well. So when it comes to revision, many things are there. Hopefully very soon all these things are gonna be done. Until then, take care. I'm gonna be catching up just after half an hour, and then we'll working on these few features because they are actually big ones. So it's not like I could have worked on all of them, but at least few of them we can get done today. And this is how we'll just simply keep going. Bye bye, take care, and see you.